Hey team, Miss Kraska here. Ratios. This is your learning target and topic for the day. You should be using the notes template for this video. So if you're not, pause here, go get them in your folder, put them in Notability, dual screen share. You can do this. It's going to make your life a lot easier. So some prior knowledge you're going to activate today. I can create ratios to represent data. I can write ratios as percents and fractions, and I can compare ratios. You've had experience with this. You can do this. Go get them. All right, we got our little stop and think friend here. So that means we want you to stop and think, what do all of these images below have in common? How could you describe the relationship? So what do they have in common? Looking at them, the first one we have 3 diamonds and 5 hearts. The next one we have 3 red square tiles and 4 blue square tiles. In the last one we have 5 girls and 15 boys. So what you'll notice is each picture set is looking at 2 different things. You notice when I said them, I said 2, and I was comparing one thing to the other. I used 2 different numbers to explain what I saw. So what these are ratios. New vocabulary word for you here that we're going to use a lot. A ratio is a comparison of 2 quantities by division. So you can simply write ratios multiple different ways. We can just say them with the word 2, 3, 2, 4. We have 3, 2, 4, and 3, 2, 4. So it doesn't matter how they are written. I'm saying 2, T-O, not the number 2. So in algebra, I'm again just representing any number, because of course this one represents 3 to 4, but not all of them do. Representing 2 numbers, comparing them by division. So any number A compared to any number B. So you can write it with the word 2, a colon, or write them as a fraction. Here's the fun thing. Fractions are ratios. So ratios can express a part to a part. So in a group, maybe this is a deck of cards. Well, we know we're missing spades and clubs. So these are parts compared to another part. You represent a part to a whole. For example, here, there might be 5 girls and 15 boys, but there's 20 total people. So I could write another ratio saying 5 girls to 20 total people. You could also write it as whole to part. And in that case, you might end up with an improper fraction, and you'll leave them like that in this case. So we're often going to be seeing ratios as fractions written in simplest form, but leaving impropers, because a ratio is a comparison of 2 numbers. So let's try a couple of these that you should have some familiarity with. So we are going to write a ratio of rectangles to the total number of shapes. So what we have to do first, this would be a part to a whole here. We want to count up our number of rectangles. 1, 2, 3, 4, 5, 6 rectangles. 2, how many total shapes? We have 2 additional shapes, so that means there's 2 more, which is a total of 8. So we have 6 rectangles for every 8 shapes. You can write that as 6 to 8 or 6 to 8. And we talked earlier about simplifying fractions. Those share a factor of 2. So this is also the same as 3 to 4. You'll learn more about that later. What is the ratio of total shapes to triangles now? So kind of a little bit backwards. And it's important to know that the order of the numbers in the ratio matter. So how it's read is how you write it. So we're comparing total, first of all. So we have 1, 2, 3, 4 total shapes to how many triangles, and that's 2 of them. So I can write that as 4 to 2, 4 to 2, or 4 over 2. Again, all of these could simplify then to 2 to 1, 2 to 1, or 2 compared to 1. So there are 2 shapes. For every 2 shapes, there's 1 triangle. That's what that means. Last one, at a store, the ratio of books sold to movies sold was 8 to 2. So this means that for every, so we're kind of filling in the blank here. What does that mean? Making meaning of the sentence. At the store, the ratio of books sold to, we're comparing books to movies. So that means that this first number, 8, represents books, and 2 represents movies, because that's the order it was written. So this means that for every 8 books sold, there were 2 movies sold. Or for every 2 movies sold, there were 8 books sold. So that's just showing you have to kind of rearrange it if you're going to write it in the order that it matters. So rearranging it based on how the sentence read and based on what I knew from the first sentence.
Okay, to set up a ratio, again, we need to know what numbers are being compared and then set it up in a fraction form. So in order to figure out what we're comparing, we read the directions here, and the first item that's listed, that goes on the top, or that's our numerator. The second item that's listed, that's what goes as our denominator when we're setting up the fraction. We always write our ratios in simplest form, but it's very, very important that we leave them as improper fractions. We don't turn them into mixed numbers. Okay, so let's see exactly what that means using this table here. So Jane has a bag that contains 3 bouncy balls, 4 marbles, 7 books, and 1 orange. That's what it's showing over in this table. Right? Or what is the ratio of books to marbles? So the first item that comes up is books. If I look at my table here, there are 7 books. Again, since that's the first, that is our numerator. To marbles. Marbles, it's showing us there are 4 marbles. So that's our denominator because it's the second item. So as a ratio, as a fraction, it would be 7 to 4. Again, keep it as an improper fraction in simplest form, so I don't have to do anything else with it. The next one, what is the ratio of marbles to books? So now it's just flipped around in the other order. So marbles is first, so this time that's going to be our numerator. Books comes second, so that's our denominator. So it's just flipped this time because the order is flipped. Again, that's in simplest form, so we would leave it. Next one, what is the ratio of bouncy balls to marbles? Well, bouncy balls, there's 3 bouncy balls. And again, marbles, there are 4. Check to see if you can simplify it. It's already in simplest form, so we would just leave it as 3/4. The last one, what is the ratio of bouncy balls to total items in the bag? So bouncy balls is first, so that would be our numerator, which is 3. Now, total items in the bag. That means everything that's inside the bag. So we would add all of that together. So 3 plus 4 is 7. 7 plus 7 is 14. Plus 1 is 15. So total items, 15 items. We can simplify this by dividing the top and bottom by 3, which would be 1/5. So for every 1 bouncy ball, there's 5 items in the bag. This is the really important thing. Ratios that are greater than 1 are expressed as improper fractions, not mixed numbers. Keep them improper, but simplify. Okay, so this is where you are going to pause the video and try these on your own. Use the information in the table to write each ratio as a fraction in simplest form. So pause, try those 4, come back and watch your way through. Okay, so we're looking at a field trip statistics here. We have some information about how many students were on the field trip, how many adults, and how many buses, and we're going to use that to write our ratios. So the first one, adults to students. If I look at my table, there are 24 adults. Again, that came first, so that's our numerator. There are 180 students. That came second, so that's my denominator. When I simplify, I can divide the top and bottom by 12, and when that is simplified, then that equals 2/15. So that would be my final answer. So there's 2 adults to 15 students. The next one, students to buses. Again, students comes first, so that would be my numerator. 180 students. Buses comes second, and it's telling me that there's 4 buses, so that's my denominator. This can be simplified by dividing the top and bottom by 4, which would be 45 over 1. Again, it's an improper fraction, but we leave it as improper like that. We do not make it a mixed number. So this is telling us there's 45 students to 1 bus. So 45 to 1. Number 3, buses to people. Again, buses is first, so that's my numerator. Now, when it says people, well, students are people and adults are people, so we are looking at this total. We add them together. So with students and adults, that equals 204. So my denominator on this one would be 204. Okay. Simplify, I can divide the top and bottom by 4, which is 1/51. So as a ratio in simplest form, 1 to 51. 1 bus to 51 people. And the last one, adults to people. Adults is first. Well, there's 24 adults. Again, people, that includes both students and adults. So when we added that, we got 204. We can simplify by dividing by 12. That would be 2 to 17 for my ratio in simplest form. So 2 adults to 17 people. Okay, so now we are going to learn how to write the ratios as fractions and then how to turn those fractions into percents. We can now use calculators for this unit. So this box over here tells you how to change the percent to, or how to change the fraction to a percent on the calculator. So we'll use that when we get to those problems. So the first one here, if 5 cups of trail mix has 2 cups of raisins, what is the ratio of raisins to trail mix? Again, raisins is first, so that's our numerator. Well, there's 2 cups of raisins, so we put 2 on our numerator. Then we're looking for trail mix. Well, there's 5 cups of trail mix, so that's our denominator. Always simplify, that's already in simplest form, so our fraction would be 2 to 5. Now, to turn this into a percent, I'm going to follow these directions that are over here in this box. It says divide numerator by denominator. Numerator, so 2 divided by the denominator 5 equals, okay, so that as a decimal now is 4/10. It says round to the nearest hundredth. It doesn't go to the nearest hundredth, so I don't have to do anything. Move the decimal 2 points to the right. 1, 2. Add zeros if necessary. We have an empty spot here, so we fill in with a 0. So that now becomes 40. And then it says add percent sign, so 40%. So 2/5 as a percent, 40%. Again, you can use your calculator for this. What does that percent mean based on the situation? Well, it was asking for raisins to trail mix, so that means that the trail mix is made up of 40% raisins. Okay. The next example, out of your 460 minutes on Zoom each week, you spent 70 minutes in math class. So those are a couple important information numbers, I'm guessing. What is the ratio of math class minutes to total Zoom minutes? Okay, so again, ratio of math class minutes. Well, you spend 70 minutes in math class. That came first, so that's our numerator. To total Zoom minutes. Well, the total Zoom is 460, so that would be our denominator. Always simplify. I know I can divide the top and bottom by 10, which would be 7/46. That's in simplest form, so 7 to 46. Now we're going to turn that into a percent, again using the calculator. So divide numerator by denominator, 7 divided by 46 equals, and it keeps going on and on. Round to the nearest hundredth. Remember, that's the second spot after the decimal. Look to the number after, 4 or less, let it rest. So the 5 doesn't change at all. So that would be 15/100. Move the decimal 2 places to the right, 1, 2, which would be 15, add a percent sign. So out of your week you spend, or out of your Zoom time, you spend 15% in math class. This is again where you are going to pause the video and try these on your own before you watch as I go through them. The first problem here, on Saturday, Trey shoveled for 5 hours and played video games for 3 hours. What is Trey's ratio of playing video games to shoveling? So video games is first, so that's our numerator. He played the video games for 3 hours. Shoveling comes second, and he spent 5 hours shoveling, so that's our denominator. Again, we're going to turn this into a percent. To do that, we use our calculator, or we can. Here's the reminder for you. Numerator divided by the denominator, so 3 divided by 5, which equals 6/10. Round to the nearest hundredth, it's already, don't need to round. Move decimal 2 places to the right, 1, 2. Fill in the empty spot with a 0 and add a percent sign, so 60%. So the ratio 3 to 5 was already in simplest form. That is a percent is 60%. The next one. Currently, Mr. Beast has 49 million subscribers on YouTube, and Pewdiepie has 107 million. What is the ratio of Mr. Beast's subscribers to Pewdiepie's? You can drop the million for now and just use the number value, because if you think about it, the millions would kind of cancel each other out when we're simplifying anyway. So again, it's asking for Mr. Beast to Pewdiepie. So Mr. Beast is the numerator, which would be 49. Pewdiepie would be the denominator, which is 107. That is already in simplest form, so I can't simplify at all. Now we're going to turn that into a percent. So again, divide 49 divided by 107, which using my calculator was something like that, and it keeps going on and on. Round that to the nearest hundredth. That's the second spot after the decimal. Look to the number after. 5 or more, raise the score. So that would become 46 hundredths. Move the decimal 2 places to the right and add a percent sign. So 46%.
All right, we have another vocab word that we would like you to write down. So equivalent ratios are ratios that have the same value. So if you think of equivalent fractions, different numerators and denominators, but the same value. Equivalent ratios have different quantities that are being compared, but in the end, they have the same value. So last weekend, Mrs. Kraska drove 250 miles in 4 hours, and Mrs. Little drove 500 miles in 8 hours. Are these ratios equivalent? So Mrs. Kraska's ratio is 250 miles to 4 hours. Mrs. Little's ratio is 500 miles to 8 hours. We need to determine if they drove basically at the same speed. So if Mrs. Kraska went 8 hours, would she have driven 500 miles just like Mrs. Little? So we can look at 250 to 4, and I can see that if I multiply 4 times 2, I will get 8. But if I do that to my second number, I have to do that to my first number. So 250 times 2 is 500. 4 times 2 is 8. And therefore, I can see that they are equivalent, or they're equal to each other, which tells me that, yes, they are equivalent. Another way that I could do this is I could take 250 to 4, and I could do 250 divided by 4, and I would get 62 and a half. And then I could take 500 divided by 8, also get 62 and a half. And that also tells me that those are equivalent. Mr. Hansen's cookie recipe calls for 2 cups flour to 8 cups sugar. Mr. Schaefer's cookie recipe calls for 8 cups flour to 14 cups sugar. So Mr. Hansen's ratio for his cookies are 2 cups flour to 8 cups sugar. And then we'll do a little H here. And then Mr. Schaefer's ratio would be 8 cups flour to 14 cups sugar. So 8 cannot go into 14, and 14 cannot go to 8. But kind of like fractions, if we find a number that they can both go into, so I know they can both go into 56. So I'm going to do times 7 here because 8 times 7 is 56. So now an equivalent ratio to 2 for 2 to 8 would be 14 to 56. An equivalent ratio for 8 to 14 would be 32 to 56, because all I did was I multiplied them both by the same number. So now we have 14 to 56. So I'm going to write this as a ratio like this. Remember, we can either write it as 14 to 56 this way with my fraction bar or with the dots, or I can even write it out 14 to 56. And then Mr. Schaefer's is 32 to 56, or 32 to 56. And so I can see that 14 and 32 are obviously not the same. So these cookie recipes are not equivalent. And then it asks me, who had a higher ratio of flour to sugar? Well, I can see that Mr. Schaefer's has 32 cups of flour to 56 cups of sugar, whereas Mr. Hansen's only has 14. So then I know that Mr. Schaefer's has the higher concentration, or the higher ratio of flour to sugar. All right, I would like you to pause the video and try these 2 questions on your own, and then come back and unpause and check your work and make corrections if necessary. So Morning Glory sells 4 muffins for every 10 scones. Caribou Coffee sells 2 muffins for every 6 scones. Are these ratios equivalent? If not, which place has the higher ratio of muffins to scones? So Morning Glories, we're going to set up a ratio of 4 muffins to 10 scones. Caribou Coffee, we're going to set up a ratio of 2 muffins to 6 scones. It's easier for us to compare if we have our second number the same. So we can convert. So basically what we're doing is we're finding equivalent fractions for each of these out of the same number of scones, basically, and then we're able to compare. So 6 and 10 both go into 30. So I'm going to make these out of 30 scones. So 4 muffins for every 10 scones is the same as 12 muffins for every 30 scones at Morning Glories. At Caribou Coffee, 2 muffins for every 6 scones is the same as, and I'm multiplying by 5 so I can get to 30 on the bottom, is the same as 10 muffins for every 30 scones. So I have found equivalent ratios with my starting ratios in order to compare. But now I can see that 12 30ths is not the same as 10 30ths, so they are not equivalent. And then which place has the higher ratio of muffins to scones? I can see that Morning Glories has more muffins per 30 scones because they have 12 muffins per 30 scones, and Caribou Coffee only has 10 muffins per 30 scones, so Morning Glories has the higher ratio. Select 2 ratios that are equivalent to 6 to 10. So I'm going to rewrite my ratio as 6 to 10. And then I'm going to compare it to each of these ratios to see if any of them are equivalent. So I'm going to write 6 to 10, 20 to 12. First of all, I can see on this ratio that my first number that's being compared is greater than my second number, which is not the case for my first ratio. So right away, I know that those are not equivalent. Secondly, I go to 32 to 50. So is 6 to 10 equivalent to 32 to 50? I'm going to change. I know that 10 can go into 50. So I'm going to multiply both of my ratio, my numbers in my 6 to 10 to make it out of 50. So 6 to 10 is the same as 30 to 50. But I can see that 30 and 32 are not equal, so we know that that's not equivalent. We have 6 to 10 and 3 to 5. I know that 10 can be divided by 2 to get to 5, so I'm going to take 10 divided by 2, do the same to my first number. 6 divided by 2 is 3, 10 divided by 2 is 5. So 6 to 10 is the same as 3 to 5, which is the same as the ratio that I'm comparing, so I know that they are equivalent. 6 to 10, and then 24 to 40. I know that 10 can go into 44 times, so I'm going to multiply my first part of my ratio and my second part of my ratio by 4, which takes me to an equivalent fraction of 24 to 40, which is the same as the ratio that I'm comparing, so we know that they are equivalent. And then I have 6 to 10 and 14 to 80. 10 times 8 would take me to 80, would take me to out of 80. And then if I do the top, 6 to 8, or 6 times 8 is 48. 48 and 14 are not equivalent or not equal, so that means that those ratios are not equivalent. Okay, so following along in your notes template, find this page, and we would like you to complete these problems on your own. So notice that there's different parts of each type of question. Complete them, and then take a screenshot of just this You Do page, and you're going to post this page into the class kick onto the slide for today. That is all that we have for you, so make sure you keep these notes in a safe place or in a place on your iPad that you know that you're able to find and access. Use them to help you with your practice on Class Kick and with your target checks. Make sure that you come to your Zooms with questions on any of the problems or anything from the video. Thanks for watching. Have a great day.